Okay, we are in example 3C now, which is going to be exciting. So the first thing I'm going to do is to rewrite this as as the cube root of 2n, that's a 2, I know you guys love my handwriting, over the cube root of 9n. Now, when you have cube roots, it gets a little bit more exciting, right? Because in order to get that radical out of the denominator, instead of just multiplying it 2 times, you have to have 3 of the same thing, right? So we're going to multiply this by the cube root of 9m times the cube root of 9m. So now I have 1, 2, 3 of the same thing, and they're all cubes, which means that my bottom gets really pretty really fast. It's just 9m, because I basically, these three things, when you multiply them together, is the cube root of 9m cubed, which is 9m. So that's our denominator. We've now rationalized it. Woohoo! Now we have this mess of a numerator. And it is a mess. The numerator is a complete and total disaster. But we're going to make it better. So what I'm going to do is I'm going to slide down here. And I'm going to take my numerator. And I'm going to rewrite it for you guys. But don't forget that our denominator is up here. We're going to need that at the end. So we're going to have the cube root of 2n times the cube root of 9m times the cube root of 9m. Now, you may say to yourself, look, all of those 3's are the same. Those indices are the same. So I'm going to put everything together under the same cube root. And that gives me the cube root of 2 times 81 times m squared n. Now you might ask yourself why I didn't put the 2 and the 81 together. And that's because I'm just going to have to break these apart again to see if I can simplify my cube root. So when I break my 81 apart, my 2 is already out there. 81 becomes 9 and 9 again. And then we have a 3 and a 3 and a 3 and a 3. Now remember, we are looking at that 3 there, so we need 3 of these 3's. So that 3 is going to come out front, and then we're going to have our cube root of 2 times 3 m squared n. And then at this point, I'm going to remember to bring that 9m back down into my denominator. So now I'm at this point, and I can see that in my numerator and my denominator, I have whole numbers. I have that 3. I wanted this to be red, sorry. I have that 3 and that 9. And guess what? Those reduce. So this becomes a 1, and that becomes a 3. So we've got the cube root, and I'm going to combine my 2 and my 3 to make 6. M squared n over 3m. Now, I really rushed through that, and I know that, that's making a lot of you super uncomfortable. So what you're going to do is you're going to backtrack that little thing, and you're going to watch it again. Then you're going to backtrack it, and you're going to watch it again. You're going to watch it as many times as it takes for this to somewhat make a little sense. And guess what? If it doesn't make sense, you can now ask a question in the quiz box. So Edpuzzle is going to insert a quiz right here for me. For those of you not in Edpuzzle, I'm going to go right on ahead to example 4a. So example 4 says we're going to add and subtract radical expressions. Now, radical expressions have to have the same radicands. And none of these are the same. We've got a 20, we got a 16, we got a 215, we got a 5. Not the same at all. But what you'll notice is that while 5 is prime, 20, 16, and 250 are not. So we are going to do 3 separate factor trees here with our 20, our 16, and our 250. 20 becomes 5 and 4, 2 and 2, 16, 4 and 4, 2 and 2, 2 and 2. 250, I'm going to do 25 and 10. And then we have 5 and 5 and 5 and 2. Now, the 16 and the 250 both have 3s as our indices. So we're going to need 3 2s out front and 3 5s out front. So these get rewritten as 2 cube root of 2, and it's negative, and 5 cube root of 2, and then my little square root of 5 out here on the end. Now our square root 20, we've broken down over here, and that 20 is a square root, so we're just going to pull that pair of 2's out front. So we have 2 and then our 5 left underneath. Now that I've rewritten this, I actually have some of the radicands that are the same. So this square root 5 and this square root 5 are the same. So 2 minus 1 root 5 is going to give me 1 or just root 5. And then our negative 2 cube root of 3 and positive 5 cube root of 3 is going to give me plus 3 cube root of 2. I said cube root of 3. I meant cube root of 2. I'm sorry. You guys know I do that in class, so it shouldn't be any different when you're watching an Edpuzzle. But these are both cube root of 2's, and so they can be combined. And all you're doing is pretending, basically, that these radicals are acting kind of the same way as variables act. Very similarly. You don't do anything to them. You just look at those leading coefficients that are sticking out front, and you're going to combine them. And that's how we get where we're going. Okay. Example 4b. It's a fun one. So you're going to have to stay with me, and we might not finish it all on this video. And if that's the case, then we'll just pick right back up on the next one. So this is saying the design shows the boards needed for bracing the back of some set scenery. Will 75 feet of wood be enough for all the bracing? So all of this orange stuff you see is our bracing. So we have a 4-foot section. I'm going to make this a really thick. We have this 4-foot section, this 4-foot section right here. I'm trying to make this super thick and it's not working. I'll do a highlighter. How does that sound? So we've got this 4-foot section, this 4-foot section, and this 4-foot section. So we have 3 4-foot sections. And then we have this 7-foot section right here, 7 feet over here, 7 feet over here, and 7 feet over here. So 4 7-foot sections. But then they've given us those lovely little diagonals. And in order to find these diagonals right here, so there's this one and this one, those are going to be the same, but we're going to have to do the Pythagorean theorem with this right triangle right here. So we get 4 squared plus 4 squared equals, and we're going to call that A squared. So we get 16 plus 16 equals A squared. And then we take our square root. Now, if I do 32 up here, we now have a pair of 4s with a 2 left over. So this is going to be 4 root 2. And we're going to pause right there, let you guys get it, and then we're going to go into this on the last video.